The Optics OSN 8800 is a highly reliable unified platform that provides large capacities and bandwidth. The Optics OSN 8800 is intended for the backbone and core layers. It can interwork with the Optics OSN 6800 or Optics OSN 1800 to form a complete end-to-end OTN network for unified management. The Optics OSN 8800 T64 is available in two variants, Enhanced and General subracks. An Enhanced Optics OSN 8800 T64 subrack provides a maximum of 6.4 terabits per second cross-connect capacities, and a General Optics OSN 8800 T64 subrack provides a maximum of 2.56 terabits cross-connect capacities. The Optics OSN 8800 T32 is available in two variants, Enhanced and General subracks. An Enhanced Optics OSN 8800 T32 subrack provides a maximum of 3.2 terabits per second cross-connect capacities, and a General Optics OSN 8800 T32 subrack provides a maximum of 1.28 terabits per second cross-connect capacities. Different from the General Optics OSN 8800 T32, the Enhanced Optics OSN 8800 T32 subrack supports packet services. Compared with an Optics OSN 8800 T64 and T32 subrack, an Optics OSN 8800 T16 subrack has the smallest cross-connect capacities, which are at most 1.6 terabits per second. The system control board slots are reserved to provide for SCC board 1+1 redundancy. The clock board slots are reserved to house an STI board and two STG boards in 1+1 redundancy. The PIU board slots are reserved to house 4 pairs of PIU board, and the PIU boards in each pair are in 1+1 backup. These auxiliary interface board slots are reserved to house EFI, AUX, and ATE boards. The cross-connect board slots are reserved to hold 2 pairs of cross-connect boards. In each pair, the cross-connect boards are in 1+1 backup. As you may have observed, the service board slots are used to hold service boards. All the service board slots support electrical cross-connection. On both sides of the subrack, a FAN board slot is present in each of the upper and lower positions to hold a fan tray assembly, which contains 3 independent fans. The system control board slots are reserved to provide for SCC board 1+1 redundancy. The clock board slots are reserved to house an STI board and 2 STG boards in 1+1 redundancy. The PIU board slots are reserved to house 2 pairs of PIU boards, and the PIU boards in each pair are in 1+1 backup. These auxiliary interface board slots are reserved to house EFI, AUX, and ATE boards. The cross-connect board slots are reserved to hold 1 pair of cross-connect boards. The cross-connect boards are in 1+1 backup. As you may have observed, the service board slots are used to hold service boards. All the service board slots support electrical cross connections. A fan board slot is present in each of the upper and lower portions to hold a fan tray assembly, which contains 3 independent fans. This slide describes the slots inside an Optics OSN 8800 T16 subrack. As you can see, 2 PIU board slots are present. They are used to hold 2 PIU boards in 1+1 backup. These 4 auxiliary interface board slots are reserved to house EFI, AUX, and ATE boards, and the 2 cross-connect and system control board slots are used to hold 2 cross-connect and system control boards in 1+1 backup. For example, the TN16UXCM. They can also be used to hold service boards. Now, these service board slots are used to hold service boards, and all the service board slots support electrical cross-connection. Last is the fan board slot. It is used to hold a fan tray assembly, which contains 3 independent fans. This slide introduces boards which have been newly added in Optics OSN 8800 V100R007. Their applications and descriptions are as follows. The main function of OTU boards is to convert client services into optical signals carried over ITU-T compliant WDM wavelengths through a series of operations such as mapping, framing, and multiplexing. The TN14LSX board is a newly added OTU board in V100R007C02. As you have observed, the TN14LSX board is a 10G OTU board. This board supports SDH, OTN, and various Ethernet services on the client side and produces one OTU2 or OTU2E signal on the WDM side. It can be equipped with long, medium, or short-reach XFP modules on the client side to address different transmission requirements. This slide presents the application of a tributary board. After receiving a client service, the tributary board performs OE conversion, converts the service into ODUK signal, and then sends the ODUK signal to the cross-connect board for grooming. The tributary boards newly added in V100R007 include TN54TTX, TN54TSC, and TN55TOX. The following will describe each of the 3 boards. First, let's look at the TN54TTX board, which is a 10-port 10G tributary board. This board supports SDH, OTN, and various Ethernet services on the client side and produces 10 ODU2 or ODU2E signals on the backplane side. It can be equipped with long, medium, or short-reach SFP Plus modules to address different transmission requirements. Then, let's look at the TN54TSC board, which is a 1-port 100G tributary board. This board can receive one 100GE service on the client side and produces one ODU4 signal on the backplane side. It supports 2 types of CFP optical module. One is the 4-wavelength 25G CFP optical module, and the other is the 10-wavelength 10G CFP optical module. Last, let's look at the TN55TOX board, which is an 8-port 10G tributary board. This board supports SDH, OTN, and various Ethernet services on the client side and produces 8 ODU2 or ODU2E signals on the backplane side. It can be equipped with long, medium, or short-reach SFP Plus modules to address different transmission requirements. Each tributary board is accompanied by a line board. As you can see from this slide, a line board receives ODUK signals from a tributary board through a cross-connect board. Then, the line board performs mapping and multiplexing of the ODUK signals and converts the signals to OTUK, optical signals carried over ITU-T compliant WDM wavelengths. The line boards newly added in V100R007 include TN52ND2, TN55NO2, TN52NS2, and TN54NS4. The following will describe each of the four boards. The first is the TN52ND2 board, which is a 2-port 10G line service processing board. This board supports backplane cross connections of multiple ODUK signals and produces 2 OTU2 or OTU2E signals on the WDM side. The second is the TN55NO2 board, which is an 8-port 10G line service processing board. This board supports backplane cross connections of multiple ODUK signals and produces 8 OTU2 or OTU2E signals on the WDM side. It can be equipped with either fixed or tunable wavelength XFP modules. The third is the TN52NS2 board, which is a 1-port 10G line service processing board. This board supports backplane cross connections of multiple ODUK signals and produces 1 OTU2 or OTU2E signal on the WDM side. Last, let's look at the TN54NS4 board, which is a 1-port 100G line service processing board. This board supports backplane cross connections of multiple ODUK signals and produces 1 OTU4 signal on the WDM side. It can be equipped with tunable wavelength optical modules that support HFEC or SDFEC. This slide illustrates the position of packet boards in a WDM system. As suggested by the name, packet boards provide a resilient LSP transport pipe to receive and transmit data packets and perform MPLS switching of the packets. Optics OSN 8800 packet boards use MPLS TP APS to provide carrier class protection for data services. They provide a great variety of MPLS TP OAM and ETH OAM methods and support bandwidth management using quality of service. The packet boards newly added in V100R007C00 include TN54EX2, TN54PND2, and TN54EG16. Next, let's learn about these boards. The first is the TN54EG16 board, which is a 16-port GE processing board. This board supports Layer 2 switching of Ethernet packets and supports Ethernet service protection, quality of service, and OAM functions. Now, let's look at the TN54EX2 board, which is a 2-port 10GE packet switching board. This board also supports Layer 2 switching of Ethernet packets and supports Ethernet service protection, quality of service, and OAM functions. Last, let's look at the TN54PND2 board, which is a 2-port 10G packet line board. Similar to the previous two packet boards, this board also supports Ethernet service protection, quality of service, and OAM functions. A ROADM board is used to add or drop any wavelength to or from a multi-wavelength. It can also add or drop a combination of wavelengths to or from a multi-wavelength. This achieves dynamic wavelength grooming in multiple directions. A ROADM board is intended for DWDM systems. The ROADM boards newly added in V100R007C00 include TN12TD20 and TN11TM20. Next, let's learn about the two boards. The TN11TM20 and TN12TD20 boards are designed for coherent transmission. They are used in a colorless and directionless ROADM solution with simplified architecture to provide colorless add and drop of 20 wavelengths. The use of the two boards helps significantly simplify ASON node configurations at the optical layer and saves a lot of slot resources. Fiber amplifier boards are used to amplify optical signal power so as to extend the signal transmission distance. Only one fiber amplifier board is newly added in V100R007C00. That's the TN11RAU2. The TN11RAU2 board is an integrated Raman amplifier board. Compared to other OA boards, the TN11RAU2 board has a smaller noise figure and generates a multi-wavelength high-power pump light, so it provides for a longer transmission distance. As such, the TN11RAU2 board helps significantly reduce the use of electrical regeneration sites. A cross-connect board establishes physical channels for electrical signals on service boards inside a subrack and grooms electrical signals by working with the service boards. The cross-connect boards newly added in V100R007C00 include TNK2USXH, TNK2UXCT, TN52UXCH, TN52UXCM, and TN16UXCM. The following is more information about these boards. The TNK2UXCT and TNK2USXH boards are designated for enhanced optics OSN 8800 T64 subracks and must be used together. Together, they offer a maximum of 6.4 terabits per second cross-connect capacities and support ODUK and VC4 cross-connections. The TN52UXCH and TN52UXCM boards are designed for enhanced optics OSN 8800 T32 subracks. Each of the boards offers a maximum of 3.2 terabits per second cross-connect capacities and supports packet switching of Ethernet services. Regarding the cross-connect granularity, the TN52UXCH board supports ODUK, VC4, VC12, and VC3, but the TN53UXCM board supports VC12 and VC3. The TN16UXCM board is designated for Optix OSN 8800 T16 subracks. This board supports ODUK, VC4, VC12, and VC3 cross-connections with packet switching of Ethernet services. In addition, by collaborating with the U2000, this board manages all other boards inside an NE, establishes communication between the resident NE and another NE, and provides the NE with a physical clock or PPT clock for the clock synchronization purpose. Spectrum analyzer boards support in-service monitoring of optical signals without impacting signal performance. Only one spectrum analyzer board is newly added in V100R007C00. That's the TN12 OPM8. The TN12 OPM8 board is an 8-channel optical power monitor board. Together with Huawei's optical doctor system, it can detect OSNRs of 10 gigabits per second, 40 gigabits per second, and 100 gigabit per second wavelengths. That's it for the main boards and their applications. Now, let's learn about the key features of the Optix OSN 8800 V100R007. The key features include 1. 100G coherent receiver. 2. The MS-OTN multi-service transport platform. 3. OSNR detection using Huawei's optical doctor system. 4. Low latency. At the transmit end, 100G signals are mapped and framed into OTU4 signals after they undergo EPDM QPSK modulation and HFEC or SDFEC processing. At the receiver end, coherent detection technology is used. Specifically, the receiver uses a local oscillator to generate a laser light that has the same frequency as the received signal. Through the interference between the laser light and the received signal, the receiver recovers the amplitude, phase, and polarization of the received signal. Besides, the coherent receiver uses an analog-to-digital converter and digital signal processing technologies to compensate CD and PMD in the fiber line and finally recovers the original signal. The Optix OSN 8800 supports the OTN SDH Packet Unified Platform and has the following merits. First, it reduces the required types of equipment thanks to its full-service transmission capability. Second, it simplifies the network structure due to its L0, L1, L2 synergy. Third, it protects operators' investments because it supports smooth network evolution. The Optix OSN 8800 supports OSNR detection by working with Huawei's optical doctor system. OSNR of any rate signals can be detected on any NE. This helps improve network quality and reliability. The Optix OSN 8800 supports latency measurements. Using the U2000, users can query the end-to-end ODUK latency.